It's all right. Go
Good
ahead.
afternoon, everyone. Thank you for joining us. We're so glad that you're here. Welcome back. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, the Science and Technology channel.
Yeah, and we're talking about another space topic, as Steve mentioned earlier today, the plasma thruster. So,
Sounds
here we go.
exciting.
Yeah.
NASA's experimental lithium-powered plasma thruster has cleared a major early test, marking another step toward future human missions to Mars. Engineers at NASA's Jet Propulsion Laboratory in Southern California recently fired the electromagnetic engine at power levels never before achieved in the United States for this type of propulsion system. Would you like to know more?
More power. Okay. The test took place on February 24th inside a specialized vacuum chamber at JPL designed for high-power electric propulsion research. During the experiment, the prototype engine operated at levels beyond those reached by any electric thruster currently flying on NASA spacecraft. Researchers say the results will guide the next phase of development and testing. Okay.
The engines use lithium metal vapor and belongs to a class of technology known as magnetoplasma dynamic, MPD thrusters. These systems create thrust by using electric currents and magnetic fields to accelerate plasma at extremely high speeds.
During 5 separate ignitions, the thruster's tungsten electrode glowed brilliant white as temperatures climbed above 5,000 degrees Fahrenheit, or for you Celsius folks, about 2,800 degrees. The tests were conducted in JPL's Electric Propulsion Lab, which houses a unique facility capable of safely evaluating electric thrusters that rely on metal vapor propellants at megawatt class power levels. Okay, this is Back to the Future stuff, man.
Yeah. Electric propulsion systems are far more fuel efficient than conventional chemical rockets, using up to 90% less propellant. Instead of delivering short bursts of powerful thrust, they provide a gentle but continuous push that steadily accelerates spacecraft over long periods.
Kind of like a hybrid.
Yeah.
Right, okay. NASA already uses electric propulsion on missions such as Psyche, which currently operates the agency's highest power electric thrusters. Over time, Psyche's propulsion system can accelerate the spacecraft to speeds of, 124,000 miles per hour. That's pretty fast.
Yeah. So what occurred to me just now while you were talking, Scott, is on Star Trek, the method of propulsion is dilithium crystals. And here they're talking about lithium, what was it? Lithium vapor? Is that what they said? Yeah.
Here.
So, I mean, how many times have we pulled technology from Star Trek and made it real? Like Uhura used to wear this big silver thing in her ear, and now we had Bluetooth, right?
Yeah.
And our iPads, Star Trek Next Generation had iPads, and Star Trek, the original, had the walkie-talkie, the communicator. Now we've got cell phones.
Right.
I mean, it's just crazy.
Yeah, no, I agree. Yep. They were they were definitely ahead of their time then.
Right. The new lithium-fed MPD thruster could eventually deliver much greater thrust than existing systems. Although scientists have researched MPD propulsion since the 1960s, the technology has never been used operationally in space.
In the recent JPL test, the engine reached 120 kilowatts of power, more than 25 times greater than thrusters flying on the Psyche. Quote, designing and building these thrusters over the last couple of years have been a long lead up to this first test, and that's according to James Polk, senior research scientist at JPL. It was probably like 18, probably. It's huge. It's a huge moment for us because we're not only showed the thrusters works, but we also hit the power levels we were targeting, and we know we have a good test bed to begin addressing the challenges to scaling up. Okay.
Yeah, remember, Scott, you used to say that these scientists, they'd work on something and they couldn't see, like sending Voyager, and it go off, and 30, 40 years later, it'd send back data, and the next generation is collecting that. Now it's starting to speed up a little bit. They're creating it and they're testing it.
Right. Yeah. Some of those guys were not around for the grand
Right.
finale. So,
Right. Right.
yeah. Now these tests are coming along faster and the results are coming up quicker. So, yeah, this is cool stuff.
So Polk observed the experiment through a small viewing portal in the 26-foot long, which is 8 meters, water-cooled vacuum chamber. When the thruster activated, its nozzle-shaped outer electrode glowed intensely while producing a vivid red plasma plume.
Polk has spent decades working on electric propulsion technologies. I guess he's not 18 then. And previously contributed to NASA's Dawn mission and Deep Space One, the first spacecraft to demonstrate electric propulsion beyond Earth orbit.
So another thing I just thought of, Scott, remember we had that segment about those 11 scientists that were killed, various manner of death?
Mystery deaths, yeah. And
this is like a scientist working on that kind of stuff that, I mean, we can be set back big time if we're losing our scientists, that are working on this stuff.
Yeah. And these guys have got a different way of thinking, right? I mean, it's not a one and done deal. It could be 1,001 to 1 or whatever. I mean, they just keep on plugging away. So that's off to them. But yeah, they need to stay safe.
Yeah. Researchers hope to eventually increase each thruster's power output to between 500 kilowatts and 1 megawatt. One of the biggest technical hurdles will be ensuring the hardware can survive prolonged operation at extreme temperatures.
A crewed mission to Mars could require between 2 and 4 megawatts of total power, meaning several MPD thrusters would likely need to be operate continuously for more than 2,300 hours. Wow, 23,000 hours.
1,000 miles.
23,000 hours.
So a little bit less than 1,000 days. So 500 days out, 500 days back.
Yeah, what are you talking about? 3 years, right? About 3 years or so.
Yeah. I wonder why it would take that long. I mean,
going a long way.
Yeah, I guess. Yeah. All right. Scientists believe lithium-fed MPD engines could play an important role in future deep space exploration because they combine strong thrust with efficient propellant use. Paired with nuclear power systems, they could reduce launch mass while carrying the heavy payloads needed for human Mars missions.
The MPD thruster project has been under development for the past 2.5 years through a collaboration between JPL, Princeton University in New Jersey, and NASA's Glenn Research Center in Cleveland. Funding comes from NASA's Space Nuclear Propulsion Project, which began in 2020 to support the development of megawatt-class nuclear electric propulsion systems for future Mars missions. The effort is managed through NASA's Marshall Space Flight Center in Huntsville, Alabama, as part of the agency's Space Technology Mission Directorate. So, cool story.
I like it. Yeah, I like it.
Yeah, so let's see when this thing gets even bigger.
Yeah.
Powerful. This is cool stuff.
We'll keep an eye on this. Thanks for joining us, folks.
Yeah. Take care, everyone. We'll see you tomorrow.